I'm really excited that we had the opportunity to implant first of its kind in a large multi-state region of a new kind of deep brain stimulator technology that's just been FDA approved. This is something that we use to treat patients who have movement disorders, where they have problems with Parkinson's, tremor, or other disorders. And in the case of our patient today, it was a patient with essential tremor so bad that the patient could no longer use handwriting to write a name or use a fork and spoon. And we were able to see a significant improvement in terms of handwriting during surgery, and we're very pleased with the results.
Over the last few years, the technology has advanced quite a lot. So where we were first just delivering the current to a very specific area of the brain, but then we started using a technology to even record some of this brain changes that are happening pretty much every second. So now it gave us an idea as to how the brain is changing every second. Then we learned that, well, we can direct the current in a specific way so that we can minimize the side effects and provide more precise delivery or energy to the brain. Now, with this device, basically you have all of that technology available in one same lead or simple lead altogether. So with that, it has the ability to direct the energy to particular area of the brain more precisely, but also record the changes that are happening constantly in the brain. So as we say, big changes come in small packages. So this is what it is basically. It's a small change from the previous, devices, but it's a big change. Hopefully will be much more improvement in a few years.
So this is an X-ray taken from the side of the patient's skull, and here's the curve of the top of the head. And what we can see is there's a tiny shadow here of where we made a tiny hole within the skull in order to allow us to thread this electrode wire down into the tremor center of the brain, where there are a few small electrodes that deliver that impulse. And then this is the actual electrode here. I'll sort of show you that. And you can see that there are these very small electrode connectors that are what deliver the message down into the tremor center of the brain. The other reason that UAMS is part of this is that we've been a leader in deep brain stimulation among academic medical centers over the past decade. In 2012, we were one of the fastest growing DBS centers in the country, and we still are a leader in many ways today. And to that end, it's very important for us to be able to get this kind of groundbreaking technology to our patients in a way that can improve their quality of life, their control over their disease, and with the best outcomes possible. And we want to do that with the best, most advanced technologies possible.
This is the most important part of any movement disorder team. A successful movement disorder team is a successful collaboration between a neurosurgeon and a neurologist. We rely heavily on our neurosurgeons to place the leads very precisely into the deeper parts of the brain. I usually tell my patients the margin of error is 0.5 millimeters, and our surgeons are very good at making sure that they are putting the leads in the right place. The results of the treatment are as important as placing the lead in the right place as we can program them.
The UAMS Multidisciplinary Movement Disorder Clinic is really a unique thing. That started as a virtual clinic where we as groups of clinicians were all sort of collaborating, but didn't actually get to meet in person. About 3 or 4 years ago, we opened an actual center. We have one clinic on one floor where a patient can check in and be seen by a neurosurgeon, a neurologist, physical therapist, occupational therapist, neuropsychologist, all during the same visit. We all get to come to that patient in their same room, as opposed to the patient having to travel across building to building across the medical center. So that sort of integrated experience, which helps people with movement disorders, is a really unique model. And we really intended that to be a patient-focused way of serving people who have Parkinson's, tremor, and other movement disorders.